today we've got to go over lesson 6.3. This is on binomial radical expressions. Remember, binomial, that means two expressions. So here's what we're going to start with. To add and subtract, you have to have like radicals. When I say like radicals, that means the same index and the same radicand. If you have the same index and same radicand, all you have to do is either add or subtract the coefficients, and then you're going to keep whatever your radical is. All right, so let's take a look at a couple of examples here. Okay, problem 1, what is the simplest form? Well, if you take a look at this problem, my radicals, both of them, are the square root of 5. For both of those, my index is 2, and the radicand is 5x. So all you're going to do is subtract your coefficients. 3 minus 2 is 1, and then keep your radical. Okay, and you can write the 1 in front, or because it's a 1, you can just write it as the square root of 5x. All right, for part B, if you look at those radicals, well, they're both square roots, but the radicands are different. Because this radicand is 7 and this is 5, they are not like radicals. So this one you cannot simplify. It is already simplified as much as it can be. Okay, so you can write already simplified or cannot simplify. And if asked to explain, your reason would be because the radicands are different. All right, and part C, if you take a look at your radicals, I have a cube root of 7xy and a fifth root of 7xy. Got to pay real close attention because on this one my indexes are different. So this one is already simplified. Or you can say cannot simplify or cannot subtract. And the reason for that would be because the indexes are different. Now, let's go ahead down to problem 3. If they ask me to simplify that, well, I look at it and they are all square roots, but all of the radicands are different. So at first glance, you look at this and say, oh, there's no way, you can't add these. But each of these radicals can be simplified. So we need to do that before we make any decisions. So I know that 12 can be broken down into 4 times 3. So that will give me 2 square root of 3. 75 can be rewritten as 25 times 3. So that will give me 5 square root of 3. And I've got to add those together. This last one will not simplify. So it's just minus the square root of 3. So here's what I would recommend you do. You don't have to, but I highly recommend it. My coefficient for this one is a 1. Please write it down so that you don't make a mistake and just forget about it. Okay, now I have like radicals. They are all square roots of 3. So I'm going to add and subtract my coefficients. 2 plus 5 is 7, minus 1 gives me 6. Keep the square root of 3, and that's your answer. All right. For the got it question down here at the bottom, I want you to pause the video, try it on your own, and then come back and check it with mine, see how you did. All right, what I would do here is go ahead and simplify each of the radicals. I know that 250 can be broken down into 125 times 2. So that will give me 5 times the cube root of 2. Then 54 can be broken down into 27 times 2. So that gives me 3 times the cube root of 2. For the cube root of 16, break that down into 8 times 2, which will give me 2 times the cube root of 2. Now, all of my radicals are cube roots of 2, so they are like radicals. Add and subtract your coefficients. 5 plus 3 is 8, minus 2 is 6. Keep your cube root of 2, and that is your final answer. Now, I'm going to put another one over here to the side, and this is my what if. I have the cube root of 3 plus 5 cube root of 3 minus 2 cube root of 7. Now, when I look at those, these both are cube roots of 3. This one, it's also a cube root, but it's of 7. So I need to combine whatever I can. I'm also going to go ahead and put my coefficient for this one so I don't forget about it. So when I combine these two together, I get 6 cube roots of 3. And then I just bring this one straight down. And that is as simplified as it will get. You're done right there. All right, next, we're going to multiply some binomials. And remember, binomial, that's 2 terms. So I've got 2 terms times 2 terms. This is when I have to either do FOIL, or some of you like it better when we call it double distribute. Okay, either way, I'm going to start out with 4 times 5 gives me 20, and 4 times 4 root 2 will give me 16 square root of 2. Then I want to multiply these two together, and that will give me 10 square root of 2. These two together will give me 8 square root of 4. Remember, the things that are outside the radical multiply together, and then the things under the radical multiply together. So here I've got 20. This part will give me 26 square root of 2. But this part out here at the end, the square root of 4 is 2. So I end up with 8 times 2, which is 16. So I now need to combine my 20 and 16 to get 36 plus 26 square root of 2. 3 minus the square root of 7 times 5 plus the square root of 7. So 3 times 5 is 15. 3 times square root of 7 is plus 3 square root of 7. Negative square root of 7 times 5 is minus 5 square root of 7. Negative root 7 times negative root 7 gives me a negative square root of 49, which is just minus 7. Combine your like terms. 15 minus 7 is 8. For this part, I get minus 2 square root of 7. And that is your final answer. So now, for problem 5, I think you can do this one on your own because it's just like parts A and B, but when you get down to the end, after you do all of the multiplying, a little something different happens. So go ahead and multiply it, then come back and check yours with mine. So go ahead and pause the video. All right, so I'm going to start with 5 times 5 is 25. 5 times the square root of 7 is a positive 5 square root of 7. Okay, and that was when I multiplied the first in each parenthesis and the outside in each parenthesis. Now I'm going to multiply these two, so that's negative 5 square root of 7, and then the last ones will give me minus the square root of 49. That was from doing the inside and the last if we're looking at the FOIL method. Let's take a look at what happens from here. I know I've got my 25, but then I try to combine these two terms together. Well, guess what? They cancel each other out. And then for my minus 49, well, minus the square root of 49, that's going to give me minus 7. My final answer is 18. Okay, so this time my radicals completely and totally went away. So now let's talk about why that happens. And does it happen, how often does it happen? If you look, these two parentheses are identical, except this one has a minus in the middle, that one has a plus in the middle. Now, we dealt with these working with imaginary numbers earlier this year. So what we have here, those are called conjugates. So when you're multiplying conjugates together, you can do it exactly the way we did here, or there's a shortcut. If you remember the shortcut, it just takes about half your work away. If you'll notice, the outer and the inner canceled. Because they were conjugates, that will happen every time. So the only things I really have to multiply are the first and the last. I'm going to have to pause just 1 second and I'll be right back. All right, so to finish this one up, our shortcut would be to just multiply the first and the last. Okay, so that is it for section 6.3.